In this video, we are diving into cryptographic failures. To understand how serious these issues can be, we will walk through a PortSwigger lab that demonstrates an authentication bypass using an encryption oracle. Let's get started. The lab is titled Authentication Bypass via Encryption Oracle. According to the description, the application contains a logic flaw that exposes an encryption oracle to users. Our objective is to exploit this flaw to gain access to the admin panel and delete the user named Carlos. The lab conveniently provides us with valid credentials, so let's begin by accessing it. This is the home page of the lab, and I will log in using the given credentials. While logging in, there is an option called Stay Logged In. I will make sure to check that before submitting the login request. Now let's look at this request in Burp Suite. We can see two cookies being set, a regular session cookie and a new one called Stay Logged In. That's interesting, so let's keep that in mind. Next, I will browse the application and open one of the blog posts. I'll go back to the home directory and click on View Post. On the post page, there is a comment form. I will submit a comment, but this time I will intentionally provide an invalid email address just to see how the application responds and whether anything useful is exposed. Now let's inspect that request and response in Burp. We can see that a new cookie called notification is being set. The application then redirects back to the post page using a get request. I will send the get request to the repeater. At this point, I'll copy the value of the stay logged in cookie and paste it into the notification cookie field in the get request. When I send this request, let's look at the response closely. We can now see a plain text value in the error message that looks like a username and timestamp. This tells us that the cookie content is being decrypted by the server and reflected back in the response. That confirms we are dealing with a decryption oracle. Now let's try the opposite direction. I will go back to the comment form and submit another comment. But this time I will use an email value where the username is administrator followed by the timestamp we just discovered. I will submit the comment and check the request in Burp Suite again. We can see a new notification cookie value which is different from before. I will copy this value and send it to Burp Decoder. First, I will URL decode, then base64 decode. Once decoded, we can see the data in raw bytes. The error message prefix invalid email address takes up the first 23 bytes, so I will delete those bytes. After that, I will re-encode the data using base64 and the URL encoding. I will copy this new value and paste it back into the notification cookie, then send the request again. This time the response tells us that the input length must be a multiple of 16 bytes, which strongly suggests a block-based encryption algorithm. To fix this, we need to pad our input. I will go back to the comment form and add 9 padding characters before the administrator value, then submit the comment again. Once more, I'll copy the new notification cookie, send it to the decoder. Again, URL decode it and then base64 decode. This time, delete the first 32 bytes. That removes both the error message prefix and the padding. And then encode as base64 and then URL encoding. After re-encoding the data, I will paste it into the notification cookie and send the request. Now the response cleanly shows administrator followed by the timestamp with no error prefix. That means we have successfully created a valid encrypted value for an administrator login. Next, I will take a request to the home page and send it to the repeater. I will completely remove the existing session cookie and replace the stay logged in cookie with the crafted value we just generated. When I send this request, we are now logged in as the administrator. Finally, I will navigate to the admin panel. From here, I will access the delete user functionality and send a request to delete the user Carlos. The server responds successfully and the lab is now solved.